It's an exciting time to be here as we connect with our past and look forward to what may be coming in the future in human spaceflight to the moon and hopefully beyond. My name is John Charles. I'll be the moderator for this session. I'm the scientist in residence at Space Center Houston. I retired from NASA about 1.5 years ago, and I've been living out my childhood fantasies playing here with all the artifacts at Space Center Houston, and it gives me the opportunity to sit on the same stage with heroes of the Apollo era, people that actually did the work that I only dreamed of doing when I was a young 14-year-old watching on a black and white TV. We have with us today two individuals who worked during the lunar surface exploration activities. That is the work that was done on the moon. If you think about it, that's the reason for the Apollo moon missions, was not just to have a big rocket or to have a lunar landing. The idea was to get to the moon and then do something useful on the moon. And these individuals will talk with us a little bit about it today. We have Arthur Schmitt, who I understand goes by Larry, who was involved in the mission operations activities and especially on the later missions, helping navigate the lunar rover along on the surface. And we have Wendel Mendell. Please note the pronunciation and the spelling. He is an icon of lunar science as far back as the early days. He came in 1963 and was here for the lunar landings. And Dr. Mendel has been involved in understanding the results of the lunar samples and the lunar exploration, and in rewriting the textbooks about what the history of the moon was all about. So with that brief introduction, I'd like to let each of them describe their experiences during the Apollo program, if possible with emphasis on Apollo 11, but other interesting stories you may have. And then we'll open it up with questions and answers toward the bottom half of the hour. So, Mr. Schmitt, please tell us a little bit about your experience in Apollo and what your recollections are.
Oh, thank you. Ask a question anytime you'd like. He said I was a hero. I don't view it as such. I just had a job during Apollo 16 and 17 that was a whole lot of fun. And it was so much fun that I still like to talk about it. So every chance I get to come and talk about my job that I had back then, why I do that. So that's why I'm here today. And I was the navigator for the rover. You've seen the rover, I'm sure. And while they were on the moon does not have a dipolar magnetic field where you have a compass. It has a gyro on that rover, and we had to set up the gyro. So the way we did that was we used the sun. Of course, the sun rises in the east, so the shadow points west in the morning, and at noon the sun's behind you, so it points north. So it was easy to figure out the sun angle, and we used that to align the gyro. And from then on, the rover, the astronauts on the rover gave us coordinates in range and bearing, and I was on the ground, and I calculated I used those coordinates in range and bearing to figure out coordinates in Cartesian coordinates where I could plot it on a map. And that's how I kept track of the rover while it was on the moon, and that's how we set up the rover to go on the moon. If you've been in mission control, if you haven't gone on the tour to mission control, you need to do that. It's really an interesting tour, and it's very, very realistic. I was not in the main room. I was in the back room. I was in the science support room, and I had a big map in the science support room and an overhead projector. And when you're in mission, when you go on this tour and you look at the displays that they have, they're very realistic. But the one on the immediate left, for Apollo 11, they just had an animation of a guy coming down the steps of the rover. But during Apollo 16 and 17, that would have been my map. So my map would have been displayed there for the front room, the MOCR, and the rest of the world that wanted to look in and see what the astronauts were doing on the moon. While I'm thinking about the mission control and the tour, there's a couple of things that they don't tell you when you go on that tour that's kind of interesting. One is the dress code. The dress code that we have was formal. I had a new suit and a vest, and I shined my shoes before I went to work every day. By the time things got going in there, why flight controllers shed their coats and usually their ties, and they were in their shirt sleeves, and so that's usually what you see on television. But we considered it very serious business, and we wanted to be very professional, so the dress code was very formal. Another thing was everybody smoked back then. Almost everybody smoked. So the room was full of smoke. My SSR was full of smoke. They smoked cigars or cigarettes. And, you know, if you didn't smoke, why, you come to work and they're always offering you a cigarette. So that's, you'd consider it a hazardous environment today, I suppose. Anyway, that was a lot different. But it was a lot of fun. There were 2 shifts that we worked, 2 12-hour shifts on duty, and then the whole shift was 14 hours because there was an hour before you went on console that you briefed the team, or that you got briefed by the team that was leaving, and an hour after you left the console to brief the team coming on. So you were in mission control for at least 14 hours. And my counterpart on the other team was a lady named Anna Culla, and I could remember telling her she didn't want to go home, you know. So she was up all night, and she'd be doing the planning for the next day, for the mission we were going to execute. And she was excited, you know, and I'd say, Ann, you got to go home, get some rest, you know. And, oh, no, I got to see what's going on. So it was that interesting, and you know, it was really hard to go home. I can't hardly describe it because it was fun. I really enjoyed doing that. Let's see, any questions?
Well, let's move on. Let's let Dr. Mendell speak for a minute, then we'll open up for Q&A after that, okay? So, Mendell, why don't you tell us a little bit about your perspective on the Apollo program, Apollo 11, and the science that came from the lunar surface?
I assume I turned my mic on. The AV guy explained that when I hit the switch, it goes from red to green, but I didn't tell him I was colorblind. Larry came to work at the Manned Spacecraft Center in 1962, which is the very, very beginning. I was a year later, fresh out of college, and got placed in an organization called the Lunar Surface Technology Branch. And it was part of a larger organization whose job it was to write down in a formal document all of the characteristics of the moon, of the space environment, radiation, meteoroids, and so on, so that the engineers could design the spacecraft and the lander and the operations and such things correctly. And in those days, there really wasn't very much known about the moon. And so part of our job was to try to do various experiments or to let contracts to aerospace companies, was what we primarily did, to study various aspects of the moon and try to understand what that environment was like. In the late 60s, that group got transformed into a PhD level research group of the kind you would find in a university department. Primarily people who were experts at studying samples, because the big deal was to bring back samples from the moon which would tell us things that geologists and geochemists can determine about where the moon came from, what its characteristics are, what its relationship is to the Earth, what sort of processes might have occurred on the moon. So I was in the middle of that science research group, and it was very exciting for me because as a person interested in science and interested in new discoveries, it was an extraordinarily exciting time. Now, the reason I'm on this stage is because during Apollo 17, I did sit in a third floor on mission control at a console whose buttons had largely been disabled. I was a scientist, so the main concern for me was that I wouldn't screw up anything. So I could talk to a contractor who knew about the experiment that I was involved with. I could talk to a NASA employee somewhere, and I could listen on the loop to the flight operations director and things that were happening. The experiment I was involved with on Apollo 17 was in orbit. It wasn't on the surface. And it was an infrared detector that would map the thermal properties of the moon, because I had been working on that topic since 1963. And eventually, the results from that experiment became my doctoral thesis at Rice University. So Larry talked about wanting to work for a long time in mission control. I really didn't have that much of a choice. Anybody who's familiar with the science experiments that go on today, you can look at the scientific papers and see a long list of names of graduate students and professors and research scientists, all of whom are part of the science team. On my science team, there were two people. There was my thesis advisor and me. And he was an infrared galactic astronomer and didn't really care much about the moon. But he had taken on this experiment because he was an expert in the technology, and he sort of did it so that I would have some reason to exist. So we had to divide up the 24-hour day, and he got the 8 a.m. to 8 p.m. shift, and I got the 8 p.m. to 8 a.m. shift. Now, you may think, okay, boy, you drew the short straw. The interesting thing was that the Apollo astronauts lived on Houston time. So when I was in the mission control at my console at night, the astronauts were asleep. They were asleep on the surface. Ron Evans was asleep in the command module. When astronauts are asleep, they turn on all of the experiments in the command module and just let them run, because they're not interfering with anything. And so when I was there was data coming in. I got to see the exciting things that we were hoping to find and measure on the moon. And when my thesis advisor was there, they were constantly turning things on and off, and people were interrupting him, and he got very perturbed because he thought his experiment should be more important. I guess I have one war story, because as a scientist, I wasn't as much deeply involved with the operations as, say, Larry and his colleagues were. So one of the things they would give at us were little pocket cards about the size of a business card that would give the times for very special events. The Apollo 17 launch was delayed for about 2 hours because of a technical issue, and when they finally took off, they changed the trajectory slightly so that after, I forget, 3 or 4 hours, they were actually back on the timeline that was in the pre-mission plan for operations, with times for everything was going to happen. And it was a little confusing because there was a time, sort of a real time, and then this kind of imaginary time that agreed with all of the operations. So it's in the middle of the night on my console, and my console, as I say, is disabled, and suddenly on the left side, a button starts flashing. And I looked around and tried to decide what to do, because in my room there were nothing but little groups of scientists. All the really operations people were downstairs in the big mission control. So I pushed up the button, and a voice asked, "Is this the Johnson Space Center?" And I said, "Yes, it is." And after a minute or two, I began to realize that I was talking to an Air Force officer who was under Cheyenne Mountain in Colorado, where they have all of the radars and nuclear warheads and everything else. And this Air Force officer wanted to know what was the time of reentry of the Apollo 17 command module. The reason being that it might look like a ballistic missile coming in from the Soviet Union. And they didn't want to make a mistake. Of course, I'm the worst person to ask this of. So I reached in my pocket of my shirt and pulled out the little card. I was pretty sure the times in that card were correct because of all these trajectory manipulations. And I said, well, I think it's coming in at, I forget what the time was, 10 a.m. or something like that. And the officer says, is that Zulu? I said, is that what? He said, Greenwich Mean Time. Well, as an astronomer background, I understand what Greenwich Mean Time is. And I said, no, I think this is Central Standard Time. And he said, okay, well, thank you very much. And he hung up, and then I started to worry. So I got on the loop, and for the few people I could talk to, I said, I think I should tell you about something. Well, it turns out the time I gave him was correct, and the flight operations officer, whom I normally could not talk to, but who could listen to me, congratulated me on saving the space program. That's my one war story. I would like to say, though, that as a scientist, we were really interested in and excited about what the astronauts were doing and why they were there. Now, Larry didn't tell you this, but in the science support room where he sat, there were a group of geologists, all research geologists, who had been intimately involved in the planning of the Apollo 17 mission, trying to understand and answer certain very important questions about the moon, which they thought that the Apollo 17 landing site would tell them. And so those were the people that I worked with, and when the astronauts had completed their operations, the results from the experiments, the results from the lunar sample collection, everything came back to here, actually, and were examined and then distributed to other scientific research groups. So see, what was I going to say? So the geologists were, I wanted to say one more thing. They were astronauts, so they were jet jockeys, and with usually an engineering background, and sometimes a mathematics background like Buzz Aldrin. But these astronauts went through actually thousands of hours of geologic training to help them understand how to talk to the scientists and to understand what they were seeing on the surface of the moon. And quite frankly, some of them really loved it, and some of them hated it. And I just want to give a little bit of credit that the very best people on the surface of the moon from the scientific were, first of all, Jack Schmitt, who was a professional geologist on Apollo 17. He had a background in education in geology and still active today talking about lunar research. The second one I want to mention is John Young, who is more famous for being the super astronaut, space shuttle pilot, Gemini pilot, Apollo pilot, a legend on the astronaut corps, but he was a really good student of geology. And the scientists who sent him to the Apollo 16 site told him to look for a certain kind of rock there, because that's what they wanted. And he got there and said, those kinds of rocks aren't here. There's another kind of rock. And they said, shut up and pick up the rocks we want. The astronauts collected the samples, and all the way back home, John Young argued with the back room as to what they saw on the site. And when they got home, the geologists were wrong and John Young was right. The other one was Dave Scott on Apollo 15, and he was a tremendous student of geology, still around today, and did some really amazing things around the Handley Reel site. So that whole operations, which was planned, was also designed to return very important scientific results that helped us to learn what we now know about the moon, and really was a tremendous breakthrough in our knowledge.
Thank you, Dr. Mendell. Let me follow up with a couple of questions for both of you, but before we do, I'm negligent in my duties as the moderator to remind everybody in the audience that as soon as we're finished here, I've been asked to ask you to move quickly to the exit so the next crowd of 200 people can come in and take the seats for the next presentation. So thanks very much in advance for that. I want to get back to Mr. Schmitt and follow up, and it looks like you have something you want to say as well, but could you talk a little bit about why the lunar rover needed to have direction-finding equipment? Why couldn't the astronauts, no matter where they were, see the lunar module from where they were? There were no forests, there were no buildings, anything like that impeding their view. Would you talk a little bit about some of the peculiarities of navigating on the lunar surface?
Yeah, I'd be glad to, but first, I'd like to tell a story, if that's okay.
That's your job, yes.
In the SSR that I talked about, the science support room, there was a table, and his colleagues were around the table. These were older gentlemen at the time. These were the top geologists, I guess, from major universities around the country. So these were older guys, had beards, typically they smoked a pipe, glasses, gray hair, usually very settled and quiet, and they sat around a table. And there were two kinds of geologists. There were the guys that were interested in craters, and they were interested in the ejecta from the craters primarily. As I understand it, I'm not a geologist. And there were scientists or geology professors that were interested in volcanoes, and they were looking for younger volcanoes than the ones that made the Maria on the moon and all that. They were looking for evidence of young volcanoes, but they hadn't had much success with volcanoes on Apollo 15 and Apollo 16. So on Apollo 17, they planned these stops where we were supposed to direct the rover and to get samples of the lunar surface, and they were really looking for the young volcano kind of stuff. Well, these guys are around the table, and they're listening to us navigate around the moon, and there came a moment, and it reminds me of being at an Astros game when the Astros are behind and you get to the last inning, and all of a sudden hit a home run with the bases loaded, and the crowd just goes berserk. Well, that was what it was like in the SSR. You see, Harrison Schmitt, that he mentioned, got to a crater, I think they called it Story Crater, and he picked up a rock and he said, "Hey, I found an orange rock." An orange rock. Well, they thought that was kind of a sign of a young volcano, and these guys just went, they levitated. An orange rock, My gosh, and the crater guys will say, "Oh, it's nothing, it's nothing. We just want to go on." Well, Jim Lovell, he was one of the astronauts from one of the earlier missions. He was there kind of like a referee, You guys sit down, take it easy, take it. It was like a food fight in a high school cafeteria. They were yelling it. Oh my gosh, they were excited. I never will forget that moment. Very exciting. Anyway, the rover. As I said, the moon doesn't have a dipolar magnetic field, so you can't use a compass, and that presents a particular problem. So the rover had a little gyro-driven compass, and they could spin up the gyro and it would hold the needle steady as the rover turned. But the sun, as I described, makes a shadow, and for any given time we can calculate, using the same kind of mathematics that they do for celestial navigation on boats, the sun angle. And so after the astronauts got out of the LEM and sat on the rover, they would park it where there was a little gauge. It pointed directly down the sun, and when they said they're ready, we took the time and we calculated the sun angle, and then they could torque their compass around and set it. Well, the rover also had a little computer that counted the revolutions of the wheels, and once you had it set, it could count revolutions of the wheels going north and south, or revolutions of the wheels going east and west, and it would calculate the range from the orbit. It would calculate range and bearing. So that was a safety feature of the rover, so the astronauts would know how to get back to the rover if it broke down. But they would read out range and bearing to the ground, and on the ground I could calculate latitude and longitude on the map and plot on the map where these geologists could see where they were. The geologists knew where they wanted to go to certain craters. And if the astronauts needed directions to go to a given crater, well, I could do that. I could tell them which direction to go to help them out. And we planned the EVAs on, the EVAs EVAs are extravehicular activities outside of the limb, and there were 3 of them on each mission, but they got more complex on each mission. On Apollo 17, they made a big loop. And the idea of the EVA was to take the astronauts first, farthest spot away from the lunar module that they wanted to go to get samples, so that as they used the consumables in the PLIS, their portable life support system on the back of the spacesuit, they would get closer and closer to the limb. And the idea was that if the rover broke down, they had to walk back, and that was a flight rule, and we had specific constraints on walk-back time. We had to keep track of that to make sure that if something went wrong with the rover, they could get off of the rover and walk back and get in the limb before they ran out of oxygen.
Okay, that's great. That's a good little bit of background that I think I've used in my life to plan my excursions, is to start as far away as possible and always be working back in case you had to walk home. I wanted to ask Wendell one more question before we go to Q&A from the audience, and that is, given that the geologists were capable of many things such as levitating and preventing thermonuclear war, how did they find time to rewrite the books about, the textbooks about lunar history? What can you say a little bit about the revisions to lunar history between the time that Apollo started and the time that we analyzed the samples?
How long do you want me to talk? 5 minutes, he says. Okay. Before the Apollo missions, there were debates among very famous and intelligent and educated people about exactly what the moon was. And one Nobel Prize winner believed that the moon was just a collection of pieces of things that were part of the formation of the early solar system, and that when we landed on the moon and picked up things, we would pick up pieces that were formed at the time of the formation of the sun and learn about the processes that went on in the early formation of the solar system. However, people with geological backgrounds, and one of the more famous ones was Gene Shoemaker, believed that the features on the surface of the moon, particularly in the lunar mare, looked like lava flows. And if they were lava flows, then that implied something about the heating history of the moon. The moon at one time had been hot. The pieces had sort of melted and differentiated like the Earth, where there's a crust and a mantle and a core. And so the moon would have layers to it, and that the lavas from the mare would be from the hot magma under the crust. And then there were geologists who believed that the circular features on the moon were volcanoes. And at the time, in the 50s in particular, anything circular on the Earth was called a volcano. And if they studied the rocks around it and they didn't seem to fit the idea of a volcano, they were called cryptovolcanoes, meaning they were round, so they must be a volcano, but we don't know exactly what kind of a volcano this was. So one of the debates on the moon was whether these holes on the moon, which we call craters, were created by some other thing that came in and struck the moon and created this big hole, or whether they were explosions from the hot magma underneath. And I still remember a debate the night before the Apollo 11 launched over 2 guys on our educational TV channel debating whether these volcanoes are impact features. So these are very simple, fundamental, big questions. And the first lunar samples immediately answered some of these, that the lunar mare were basalts, they had been lava flows the moon had been a hot object, it wasn't formed cold, and that the features on the moon were impact craters and not volcanoes. It was only in 1962 that Gene Shoemaker's thesis on the Barringer crater in Arizona proved that this was not a volcanic feature. It had actually been formed by something coming in and hitting the Earth. And one of the big revelations over time was that if the moon was near the Earth and had seen all of these things hit it, because you can see the holes, they must have hit the Earth too. So people began looking at the Earth for impact craters and finding them, actually, once they understood how to look for them. And you may or may not know about the famous story of the demise of the dinosaurs, which is attributed to a very large asteroid impact several 100 million years ago. And that whole idea, which is now pretty much scientific canon, would have been impossible to imagine before we went to the moon and Apollo. So there are a lot of other things that I could talk about, but those are some of the really big questions that seem so simple today, but were really in debate at the time of the Apollo launch.
Good. Thank you, Wendell. I'd like to open this up now to questions from the audience, and shout out your short question when I point to you, and I'll repeat it for the C-SPAN and the folks at home. Right in the middle, yes, sir.
For Dr. Wendell, NASA set aside samples from 50 years ago in hopes that they could learn things when testing technology had advanced over the years. Now they're releasing those samples. What questions do you think that today's testing will answer from analysis of those samples?
The question is, from the audience is concerned as to Dr. Mendell about the samples that NASA has archived for the last 50 years or so from the Apollo landings that are now being released for scientific analysis using 21st century techniques. What expectations does the lunar geology community have for insights from these pristine, untouched samples?
I guess I should have done some homework. Next question. No, that's really important. What you and actually everybody else in the world does not realize is that when the big bucks were spent on the Apollo program, some of those bucks, not the huge ones, but really good-sized ones, were spent in universities creating new research facilities that could analyze geological samples in very tiny quantities. Now, your picture of a geologist may be that it's a person dressed in jeans in a pickup truck, goes out somewhere with a hammer, knocks off pieces of rocks, and brings them back to his laboratory, and that's pretty much it, and also drinks a lot of beer. That's a geologist. So they're used to having samples that weigh kilograms, big things, rocks. In the Apollo program, when a lunar sample or a piece of a lunar sample was allocated to a scientist, the quantity of material was measured in milligrams, like pills in your medicine cabinet. Very tiny amounts. And yet somehow the instruments had to look at these very tiny samples and reach very broad conclusions about what the whole rock was alike and ultimately what the whole moon was alike. And so that was one of the big breakthroughs in sample analysis at that time. Now, so the samples were taking care of the samples has been an evolving process. But right now, every lunar sample that was brought back, let's just say a rock, and you'll see that it has a number. That number means something associated with the mission and when it was picked up. And then that rock has been subdivided into tiny pieces, and every tiny piece has a subset number after that. And there are huge dossiers of paperwork of where every piece has been, who it was sent to, what happened to it, if it's been returned, and every scientist who gets a sample has a security procedure of how to keep it from being stolen. And the sample process is audited every couple of years by the the government, and it is a painful process. But all the paperwork is kept like that. There are samples that have never been touched. They're called the Pristine Samples for various reasons. And in particular, there are two of the cores, is it one or two cores, that were drilled into the surface of the moon and then extracted as a stack of material. And they have been kept in the tubes without ever being opened. They've been x-rayed, so we know kind of the structure of the things that are in them. But the actual material itself has not been examined. Now, some of the other cores were examined, and I have people who sat there and I know people who took the tube, cut it in half, filleted it like a fish, took one half, covered it with epoxy just to preserve it, took the other half, and with tweezers picked out tiny pieces every couple of centimeters over 2 or 3 meters of core. Very tedious work to try to understand the layering under the surface of the moon. In recent years, there's been some breakthroughs in the analysis of the lunar samples, which imply that there was more water involved in the formation of the moon than was thought in the early days. And one of the things that's being examined in the new samples that are opened are some of the stories of the origin of the material in those cores with new insights from what we have recently learned, say in the last 2 to 3 decades of, maybe a couple of decades of studying the moon and new ideas about the origin of the moon and where it came from. So the types of examinations that are being done on these newly opened samples are really rather different and more sophisticated and ask different kinds of questions than we would have asked in 1970 when they were first brought back.
Very good. Another question. Any questions in the back? Yes, please. Yes, sir. Yeah, the question concerns how the mission control, the map showing the lunar landing site, has the lunar module perfectly centered in the map, whereas the lunar module may not have landed at the target site and may have been downrange in the case of Apollo 11.
Well, I didn't work on Apollo 11. I was on 16 and 17. I understand Apollo 11 was a little off from where they had planned to land. Apollo 16 and Apollo 17, they were very close. But generally with the map and the overhead projector, the planned stops and the location of the orbiter and the LEM were all kept within view on the map. So the LEM would have been on the right-hand side in the lower corner from where I was looking at it, and would have been tracking the rover as it went around the planned track for the EVA. So we didn't try and keep the rover centered in the middle. Does that answer your question?
Is there another question? Let's see. Yes, in the front, please. The question for Dr. Mendell is, what is your hope and what is your perhaps wish list for experiments and investigations on the lunar surface and the Artemis program coming up?
Okay, Artemis.
We have 5 minutes left for the entire session.
No. I want to know exactly what Artemis is, because Artemis has been the name been used for several things, and I know there is a new NASA concept they call Artemis, and I'm not real clear on what its hope. Is this a landing and return and so on? Okay. This is, okay, this is the op-ed part. Quite frankly, NASA is in a bit of chaos internally about what the next steps are going to be, particularly with respect to the moon. And you may have seen news articles about a very high-ranking NASA official being demoted within the last few weeks. And part of that has to do with different perspectives on exactly what we're going to be doing on the moon. And I'm part of the crowd that really is excited about getting back to the moon and trying to learn as much as we can about it. When I began talking about going to the moon in the future, say 35 years ago or so, one of the important objectives of going back was scientific discovery and doing scientific experiments in the sense that Apollo did, which are essentially basic research. We're trying to learn about the origin of the solar system, origin of the Earth and the Earth-Moon system, and so on. So this is what's called fundamental or basic research. It's not directed toward building a better something or other. In the recent decades, and say the last 10 years, 10 to 15 years, the emphasis in talking about going to the moon has shifted from trying to do scientific exploration on a lot of different sites to creating a facility and trying to create a permanent base or outpost of some kind. And in order to support that outpost, making use of the resources that exist on the moon instead of importing everything from the Earth, which is extraordinarily expensive to do. So, in other words, living off the land. So this aspect of lunar operations has risen in importance, and I suspect, and I've even argued this in some places, that the focus on exploration in the upcoming Artemis program and programs like that will be more aimed early on at resource utilization on the moon and learning how to bootstrap ourselves into a permanent presence as opposed to the more basic research questions that were, say, at the fore 50 years ago.
Good, thanks. Let's do one more question. Yes, ma'am, in the middle here. Yes. Second, Dad?
Did she say Dad?
Yes, I was so fascinated by the dad thing. The question for Dad is concerning since he did a lot of calculations of the walk-back times of the astronauts on their rover to get back to the lunar module before their life support ran out, expired. The question was to him, did the astronauts ever disagree and say they could go further or weren't so concerned about not having any oxygen to breathe?
Yes, Heather, they did. They wanted more time. You know, they thought they had plenty of margin, and they usually did. And for Apollo 17, we extended their margin somewhat. We gave them, I think it was about 30 minutes of margin when we first started planning 16, but by the time we got through with Apollo 17, it was down, 20, 15 minutes. They wanted to stay more. They were having a good time too. But we had very strict flight rules about walk-back times and margins that were just based on safety. And you didn't want them to run out of consumables before they got back into the LEM and could repressurize the LEM and be in a safe environment.
Good. From a non-family member, somebody in the back, is there a question? Oh, okay. Yes, sir, in the front here. I can't repeat that question as vigorously as it was just expressed, but the question relates to the fact that you were fresh out of college when Apollo was happening, especially the Apollo 11, when you came in 62 and in 63. What was your sense of the future, in the sense that you might still be talking about it and still be excited about it 50 years later? As 20-year-olds, did you imagine still being involved and engaged and being in front of an audience 50 years later?
No, I could not have begun to foresee what was in store. I enjoyed what I studied in college, and I enjoyed my first jobs at JSC, which was calculating reentry trajectories for Gemini spacecraft. And I was at a desk with a slide rule and a little calculator and some equations, and it was interesting, but it wasn't exciting as being involved in Apollo. I had, in my 40 years working for NASA, I had many assignments that were very exciting. I got to fly on helicopters and airplanes. I got to go out on a ship in the middle of the Atlantic for secondary recovery for some of the Gemini missions. So I had a lot of really interesting work. And for you who are thinking about science as a career, as something to study in high school or college, I can tell you that in my experience, it was well worth it. It was just a lot of fun. It was interesting. It was a lot of work in school, and the secret, in my opinion, to science, to mathematics, is just do your homework. It's another language that you've got to learn, and you can't get behind in science class, but it doesn't take any special abilities. Don't let them fool you. You don't have to be super smart. I'm certainly not. But you do have to do your homework, and you have to be interested in your subjects, and so I would recommend a career in engineering or science to anyone. My experience was it was a lot of fun for 40 years.
And for Dr. Mendell, any reflections, any message that you wish 20-year-old you had told 50-year-later-old you?
When I was young, you're in the moment. And as a person interested in science and answering the questions about the moon, there were just constant discoveries being made. I could go hear lectures by Nobel Prize winners who came to study the lunar samples. It was just really an exciting time. But we all just assumed it was going to go on. And then the question was, what was next? And of course, pretty quickly, it became clear that there weren't going to be any more missions, and it was just difficult to accept that and try to figure out how to continue our findings in an environment where there was not going to be any Apollo. And in fact, we weren't the only ones that felt that. There were people all around the world who just couldn't understand why we stopped. And what people didn't realize is that the Apollo program was a political decision and not one based on some sort of long-term understanding of the history of the world or the universe. And that political decision came to an end, and since then we've had a lot of other political decisions, and you probably know the story.
And with that final thought, ladies and gentlemen, please join me in thanking Larry Schmitt and Wendell Mendell.